Hello all and welcome back. So from this video, let us continue our discussion on complexity analysis and learn about time complexity. So let's get started. Now coming to time complexity, the below are actually the two questions which you surely gonna get asked in any interview you give. So the first question is actually going to be, can you tell the time complexity of code or solution you have written? And second is going to be, can you improve the complexity? By the end of this module, I'm going to be very sure that you will be able to answer both of these questions as well as think on what different approaches or kind of complexity you have to aim for your answer. So now coming to time complexity, what our aim is that for a particular algorithm which we have written, so let's say if I have written a algorithm, algo, right? Let me use white color for this. We want to actually have a function which tells me how much time does our algorithm A gonna take. Okay. Now, if we are talking in terms of function, then surely this function should be dependent on something, right? So one of the things which I think it should be dependent on is actually the input size or the size of the problem which we are solving for. For example, let's assume we are given an array of size 10, right? So n is equals to 10. Now, if this size becomes, let's say, 10,000, then I am sure that the time which I took for array with size 10 is surely going to be less than array with 10,000 elements, right? So my approach or my idea is that I want to find what are the different factors, and I think that input is surely one of the factors on which our time is going to get dependent, right? So this is how I want to find the relation. That is, what should be the overall function on which my algorithm, a particular algorithm which I have written, depends with respect to the input size. Okay. So with that in mind, now let us actually fall back to the very basic approach. The very first thing which I thought when I kind of was learning about time complexity is that, hey, why can't I just run the algorithm, keep a stopwatch, and then understand which one is better, right? So we are going to do something very similar. We are going to do something a lot similar. So let me take you to this code. Yeah. So let me write time and space, or let me just do time complexity. Here what we are going to do is, for few algorithms, okay, namely the bubble sort and the merge sort, we are going to run this with a timer in place. So let me just copy the code for that. So I have written a code for this particular thing. Now what this code does is that, let me just quickly explain you the code. So this is your merge sort algorithm, the one which we have studied, just a similar kind of a implementation. It will be sorting an array which you give to it, and before calling this function, we are just making sure that we are getting the start time in nanosecond and end time in nanosecond. Okay, so time is a module which I have imported just, right? So my idea is that I will be sending it different inputs. Okay, the inputs are gonna start from 10, then 10, 100, then 1000, then 10,000, all the way to 10 to the power 7, 10 to the power 6, and we are gonna see that exactly how much time is our algorithm going to take. Now I'm gonna do the same thing for my bubble sort, and then I can compare that, okay, which one is better, right? So that is one way we can of course find out the time complexity. So let us see if we can do the same thing. Let me run this. And we see that, okay, it has given us a result for till 10 to the power 6, and after stopping for some time, it is giving me the result for this as well. And this is the result. Just to show you, like, let's go 86,000, let me run it again. It is 80,000 by now. Now, if I run it again, let us see the result. So it is 21,000. Okay. So we can see that, okay, result is changing, should be fine. Now let me do the same thing for my bubble sort. Again here, done the same thing where we have a algorithm, bubble sort algorithm, which we have already studied. I'm going to run this. Just before running, I'm going to have a start time and end time. The input is going to be from 10 to all the way to power 10 to the power 6. Okay, so 1 million. Now let me do this as well. Let's see how much time it's going to take. Okay, so we see something that for the first 3, like till 1000, it was almost quick, just like bubble merge sort, right? But now it seems to be taking some time. So for 10,000 elements, okay, it has given the result to us, and now it seems to be working for 1 lakh, right? So 10 to the power 5. So a few things are there which you have of course learned from this analysis, and this is actually known as experimental analysis. So let me write this as well. Experimental analysis, right? So where what we are doing is we are just making sure that okay, the algorithm which we want to test, I am just running it with a stopwatch. Seems like a good enough thing to do. Okay, so now let us see some problems, right? Because I can feel that there are some problems which we have seen while we are doing this. So I see that okay, it is still running, it is still not giving us the result. Okay, the very first problem, okay, so let me write them as well. The very first problem or limitations or issues with this approach is that there will be different times which I am getting on different runs, and this is also going to be different with respect to a machine as well. Okay, so if let's say my machine right now a lot of things are running, so it might happen that it's going to take a lot of time. If let's say you have a better machine, maybe then it can take less time. Okay, so that's the first thing. Second thing, if I make any changes in my code, so let's say if I make just few changes in my code, time can be different. For example, let's say if I create a merge function, maybe instead of this merge, if you will see, I have written directly here, right? So instead of this, if I create a merge function the way we have done, maybe it takes a lot of time. Okay, something like that can also happen. So that's another approach, another problem. Third thing is that time seems to be, okay, time actually varies with input, but we are not getting or establish a relationship, right? So what I mean by that is that yes, we are getting for input different input size, I am getting a time, but it is still not helping me to establish a relationship, a function which I can say that hey, my bubble sort or my merge sort is dependent on n like this, the time complexity is dependent on n like this, right? Along with that, there are few things more as well. We have to generate test cases. So as of now, I was sending n array from 10 all the way to 1 million size, which was sorted in opposite order. But I will have to make sure that I generate this test cases. The reason for this is, let's say if tomorrow someone is running insertion sort, if you give a sorted array to insertion sort, it actually is very fast, right? So I have to make sure that my test cases, which I'm actually passing to my different algorithms, they are not biased toward a particular algorithm, right? So generate test cases. Next part is like, let's say tomorrow if someone comes and he gives me a different overall implementation of merge sort. Maybe this person, instead of creating this left or half array, he's just using the left and right. Okay, the way we did it, left start or end kind of a pointers. Then what will I have to do is, I will have to then again check for each and every implementation, right? And the very last thing which we can see in front of us, that for very large outputs, for very large inputs, it is going to take a lot of time. Okay, so we have already seen that for the first or very small inputs, it is not even comparable. It is taking minuscule time, but for large output, large inputs, right, just like it is taking for 10 to the power 5, this thing is a lot big problem. So it is still not given me the answer. So it cannot be that I am waiting still, right? So it is the large input are time consuming. Now I would like to discuss each one of them again in detail. So the very first one says that different machines are gonna take different times, and that actually is true. There is one more caveat to this. Like let's say for example tomorrow if your internet or your machine is slow, then you cannot say that okay the algorithm is actually slow as well, right? If your internet is slow tomorrow and Google is taking up time to load, that doesn't mean that Google is overall slow, right? If it is not giving you the result as quick, that is not on which you can say that hey the algorithm which Google has written seems to be slow. In a very similar manner, maybe I have written the most optimized approach of doing the merge sort, but because your machine is a lot slow, okay, it is taking a lot of time, but that doesn't mean that my algorithm is having any problem, right? Second one is of course few changes, okay, time can of course be different, so it is not feasible that hey I check each and every small changes and then see how the time is getting changed. Third one, time actually varies with input, but we are not getting our established relationship. That was our whole aim when we started with, right? That was the whole aim, that we should be able to get a relationship, a function with respect to input size to get my time complexity. Fourth one, again very difficult, generating the test cases for different algorithms. Some test cases can be very favorable to that algorithm, some can be not so favorable, as I give you an example of insertion sort. In a similar example, let's say if you are doing linear search and every time the element is present on the very first index, right? So for this particular reason, we always make sure to get the time we are taking the worst case possible, okay? So what I mean by worst case is that I want to make sure that my algorithm which I've written, I'm able to get its time complexity in the worst case possible, because I cannot be assured that tomorrow when my algorithm is going to run somewhere, it is not going to encounter the worst case. Now what can be the worst cases? The worst case can be, let's say if you're sorting an array, it is completely not sorted, like it is in the decreasing order altogether. For linear search, it may be that the element is present in the last of your array, okay? It is not in the first, it is not in the middle, it is in the last. Because it may happen that if I get my best case complexity, let's say when the cases are favorable, it is very fast. So I cannot say that my algorithm is very fast, right? That's a problem. That's a very big problem. So we will always make sure that we are always working on the worst cases, okay? Worst case for a particular algorithm. Then the next one is check for each and every implementation. Again, if there are 10 implementation for a solution, we will not be writing those implementation. It is not feasible, right? It is not feasible at all. We will actually not be doing so much manual work where I'm writing 10 implementations of particular solution and then finding out each and every time which one is better, which one is not. And the sixth one, the last one, is large inputs are very time consuming. Now this is very important to understand, that my idea to check my particular algorithm along with the worst case, it should be actually checking on the large input as well. The reason for that is, of course, you can imagine that sorting a single element, any algorithm is going to do pretty well in that, right? It's going to be very quick. But the problem occurs when I'm actually dealing with large test cases where I'm getting a lots of things. For example, for Google, the problem occurs when it has to go through lots of pages to get the result, right? And not just let's say the first page or first which is scraped, that's the result it wants to just return, right? So these are some problems. These are actually some problems due to which we will actually not be doing this kind of analysis for an algorithm, because you can imagine if we try to do this, we will be keep on doing that. I would like to take up one very more common thing. So let's say if you have an old computer and let's say your friend has a new computer, okay? And say you run your algorithm, okay, for an input size, let's say you are doing sorting only. And for an input size, you run your particular algorithm. Let's say for input size of 10, your might be taking 5 seconds, it is taking 1 second. For 100, it can happen, it is taking 10 seconds, it is taking 2 seconds. For 1000, it might take 15, it might take 3. For 10,000, 20 and 4. So I'm just taking some numbers. Here you have to understand one more thing, that whenever I'm talking about in terms of time complexity, I actually never talk in terms of time taken. There are multiple reasons for that. We have already seen here as well that how for different runs, this time was actually very much different, right? It started with I think 86,000 something and then it is 21,000. So time complexity is not equal to time taken. This is something which I want everyone to remember always. Time complexity is never equal to time taken, and we can never actually find the time taken by my algorithm. I can never say that, hey, for this input, the time which my algorithm is going to take is this much. That's a wrong statement to make. That is something which you can never calculate. The reason for that is, as you can see, different machines, different time is there. Time complexity, when I talk about, I want to understand that how, with respect to input, my time changes. The time taken or the time which algorithm is going to take overall changes, but that is not exactly some time in seconds. So I will try to explain this a little bit more deep. If you will see, I just want to see the relation. I am more interested in finding the relation overall. So let's say if I have this as time and this as my input, I just want to see that, okay, for a particular input, when it is increases, how my time is increasing. Okay, here I am not actually worried about what the exact value of time will be, because we can never calculate that. Maybe tomorrow you say that, hey, my algorithm is taking 10 seconds, but then there will be so many variables, like at which particular time are you running, is it day or night, which is your processor. Okay, all these things will have an effect, and in the same environment as well, just like in mine, you can see that, okay, how much time this particular changes, right? One more thing you will actually see, everyone, that it is still running for like 10 to the power 5 elements. It's gonna run like it's gonna take a lot of time, and this should give you an idea about as well that how faster merge sort is comparison to bubble sort, right? How fast our merge sort algorithm, which I told you in the when I was teaching about merge sort as well, that it is very fast as compared to the other algorithm which we have studied. So you can see the same in front of you as well, right? Great. So I hope this is also clear that how time complexity is not equal to time taken. It is actually how the time is dependent on my input size. Okay, everyone. So I hope this thing is clear now.